Let's build our first logistic regression model. We're going to go Analyze, Regression, Logistic Regression. Our dependent variable is the thing we're trying to predict, so approved in this case. Credit score is a quantitative variable for us. And we've got the same sort of setup as an HP linear regression, where we need to add in our terms that we're using as independent variables, explanatory variables, in this effects tab. Okay, let's hit run, see what we get. If you've already read the previous module, you're going to know that I've made a slight mistake here, but we'll make that same mistake and then correct it again. We have 1,000 observations, 362 approvals, 638 rejections. We've got a good model overall. Our p-value for the 3 overall tests of the model is below 5% for each of them, in fact down below 0.01%. So we've got a good significant model. We have 3 different ways of thinking about whether we've got a good model in logistic regression. They tend to agree though, so you can just pick whichever one you like the look of. Down here in analysis maximum likelihood estimates, this is our parameter estimates. Credit score is significant, which is good. But we've got our strange thing that it's got a negative parameter estimate. And so this is telling us that the higher the credit score, the lower is the chance of, well, we thought we were modeling approval, it turns out we were not. If we pop in here to modify task, and in the model.response tab, we've got 2 different levels for our response, our y variable, our approved variable, 0 and 1, and you can see down here it's fitting model to level 0, so it's treating as 0 as being a success, as 0 as being the thing that we want to model. And typically we're going to want to change that to a 1 here. Everything is going to be exactly the same except the parameter estimates are going to flip in sign, but usually we're used to thinking about how an x variable will increase the chance of something occurring, and that'll typically be the thing that we're trying to model in our logistic regression model. You can see here, if you were eagle-eyed, that this one previously said probability modeled as approved equals 0, and now it's approved equals 1. And as we go down here to the parameter estimate, we've now got a positive value for this parameter estimate, saying that an increase in the credit score is going to increase our chance of being approved. Now, so we've got a few ways of thinking about exactly what this means, but a good place to look to get a good feel for it is down the very bottom here. We've got this graph, predicted probabilities for approved equals 1. This is telling us what is the chance that, from the model, of being approved with all these various credit scores along here. So our credit scores range from 300 up to 850 in principle, and so when we've got credit scores down below, it looks like about 450 or so, we've got essentially a 0 chance of getting approved for a loan, and once our credit score gets up into these high ranges above 700 or so, it looks like we've now got a chance of getting approved, of getting into the 90% range. And so this is the model that our logistic regression has fit to these data.